Hi, it's Mrs. Pope, and today we're going to be talking about solving systems of equations. One of the methods that we'll be using to do this will be substitution. We have a few different methods we're using, so substitution is today's method. Our goal is to use substitution to solve a system of equations. And keep in mind, a system of equations means more than one equation that has a unique solution. So that x and y works for both of those equations together, if there is indeed a solution. So our steps for solving, we want to solve one of the equations for one of the variables. Doesn't matter if it's x, y, a, b, z, whatever it is. Choose one of the variables and isolate it. Like this one here is already done for us. This one, there are two equations. One of them is solved in terms of just a variable. So they've already solved the first one for y. Number two, substitute that equation. We're going to substitute this one into the second equation and solve it. I'll show you how that's done. And then step three, once you get an answer, you want to substitute that value back into one of the original equations to find the other value. So let's see how this works. Here we want to solve this system. I have the first equation is already solved for 1. I'm going to literally substitute. I know what y is. Y is not a number, but I do know that y is negative 2x plus 7. So when I do this, I'm going to have 5x minus 3. I'm not going to write y down anymore because I know what y is. Y is negative 2x plus 7. So I see this y and this y. I'm just replacing it. Instead of saying y, I'm not going to use y because I want to get rid of one of the variables. I know I'm going to have y equal to negative 2x plus 7. So I'm just going to plug it in right there. So then if we simplify, we have 5x, distribute our negative 3, plus 6x, minus 21 is equal to 23. 5x plus 6x, we should have 11x minus 21 is equal to 23 by combining those like terms. We want to get rid of this, so we're going to add 21 to both sides. 11x is equal to 44. And then if we divide by 11, divide by 11, x is equal to 4. So we're not quite finished yet because we need an ordered pair. This is just the x value. Now look, we can tell what y is. Again, we know y is negative 2x plus 7. So let's just plug that in there. So y is equal to negative 2 times, we know what x is now, plus 7. So y is equal to negative 8 plus 7, or y is equal to negative 1. So our final answer would be 4, negative 1. You can always check these, plug them into the original equations, and see if you get the same answers. That means you would take x and y. So here you would plug in negative 1 equals negative 2 times 4 plus 7. Here you would say 5 times 4 minus 3 times negative 1 and see if it equals 23. And you can always check your work that way. All right, let's get some more examples. Example 2. This one is already solved for us. That's a nice one as well. It's already solved. The first one already has the equation solved for y, so we're going to substitute it in. So where we see a y in the second equation, we're going to put in negative 6x minus 27. So I'm going to have 3x plus 8 times, no more y, equals 9. I'm substituting in negative 6x minus 27. This comes right from here. So I've replaced that y with what y actually is. Now if we simplify this, 3x because that's positive 8 times negative 6x. So minus 48x. And then 8 times 27, what is that? 216. Minus 216 is equal to 9. So we have 3x minus 48x means we have negative 45x minus 216 equals 9. See where we are? Then we're going to have to add 216 to both sides. Negative 45x is equal to 225. Divide by negative 45. Divide by negative 45. Don't forget to divide both sides by the negative. Don't forget the negative coefficient. And once you do that, x is going to be equal to negative 5. Remember, we need an ordered pair, so don't forget to plug that back into the original equation to find out what y is. Y is equal to negative 6 times negative 5 minus 27. 30 minus 27, y is equal to 3. So our ordered pair, or final answer, negative 5, 3. Check that out and see if it actually works. One more example for substitution. Here we have x minus 7 is equal to 11, and this one's 5x plus 4y is equal to negative 23. This one is not solved for y or x. The easiest one to change would be the first one, because x is kind of by itself. I could just get rid of that 7y, and then it would be solved in terms of one variable. So I'm going to take this first equation here, x minus 7y equals 11, and I'm going to solve it for x. So I'm going to add 7y to both sides. X is equal to 11 plus 7y. Or you could have put 7y plus 11. Remember, addition is commutative. It goes either way. But now this is solved for x, so I can use my regular substitution now. So this equation here, this is the same as this one. It's just solved for x. So I've replaced that one in a sense for this one that's solved for x. So now we're going to start with our equation 5. Instead of x, I'm going to put this in. Plus 4y equals negative 23. So that's our second equation. Now I'm going to put in 11 plus 7y, because this was 5x, this is x, plus 4y equals negative 23. So when we solve this, we're going to distribute our 5 to our parentheses. So we should have 55 plus 35y plus 4y equals negative 23. Combine all of your like terms and solve for y. So we have y, 55 and 44, we can combine those, and we'll get 99 plus 35y equals negative 23. And then we need to get rid of that 99 because we're trying to solve for y. So let's subtract 99 from both sides. Let's see, if I subtracted 100, what would I get? So negative 23 minus 99, if I subtract 100, I'd get 123, so I should get negative 122. So, where are we? 35y is equal to negative 122. And then we're going to divide by 35. We end up with a decimal. Negative 3.485. So that's okay that we ended up with a decimal. We still would need to figure out what x is, and we could plug this back in. Uh-oh. I see a mistake. Do you see it? I hope you do. It's in my handwriting. It's totally in my handwriting. I see where it is. Maybe you do. I just saw it. So hopefully you use pencil like you're supposed to, because we're going to erase this. Look what I thought was a 44. That's because I wrote sloppy. That's supposed to be a 4y. So that wasn't even 44. So we're going to have to change this. Let's erase. Erase, erase, erase. Good thing we always use pencil. And note to self, right? Neat. This was supposed to be a 4y, not a 44. Why didn't you tell me? Okay, 55. Now, we can't combine those. We're going to combine these. So 55 plus 39y is equal to negative 23. Maybe we'll come out with something positive, or not even a fraction this time. So let's subtract 55 from both sides. So now we have 39y is equal to negative 78. Divide by 39, divide by 39, and we end up with negative 2. Much, much better. Don't get me wrong, there's nothing wrong with fractions or decimals, but it is nice when you come out with a whole number. So negative 2 is our y, and we need to plug it back into x to figure out x. So 11 plus 7 times negative 2, or 11 plus negative 14, which means 11 minus 14, is going to be -3. Our final answer, -3, -2. All right, hopefully you caught the mistake before I did and you were already correcting it on your own. Again, thanks for watching, and remember, you are responsible for your own learning, and mistakes are A-okay.